Hi, welcome to the third trigonometric tutorial titled Special Angles. In today's tutorial, we will be looking at calculations involving special angles. In terms of what you need to know, you need to be familiar with your grade 10 work on trigonometry. You also need to have gone through the first two trigonometric tutorials. Just a quick note on today's tutorial. Today's tutorial is strictly about mental calculations, or rather calculations without the use of your calculator. I have designed all of these questions for you to be able to do them without using your calculator. Please switch it off and put it away. What are special angles and why do we have to study them? All angles in trigonometry have a set ratio. In the school section of trigonometry called special angles, we are going to be looking at 5 angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Also, we are going to assume that the hypotenuse, or the arm that subtends the angle, is equals to 2. The reason we study special angles is so that we can become more acquainted with doing mental calculations in trigonometry that might not seem important at the moment, but think about this. You come across a situation where you have to work out sine of 30, or rather sine of 31 or 32 degrees. You don't have a scientific calculator at your disposal. How would you work that out? Well, sine of 30 degrees is going to equal 1 over 2, or a half. That is fairly similar to sine of 32, so it will allow you to make some estimations, or rather guesstimations, about calculations. What are the ratios in special angles? Remember I said that the R value is always equals to 2. I'm going to draw a table that has the x values and the y values of each of the 5 angles. Of 0 degrees, the ratio has been calculated that x is equals to 2, y is equals to 0, when the r value is equal to 2. Of 30 degrees, it's equal to root 3 and 1. Of 45 degrees, it's equal to root 2 and root 2. Of 60 degrees, it's equals to 1 and root 3. And of 90 degrees, it's equal to 0 and 2. You need to remember this table. You need to find a way of memorizing this table in order to do special angles mentally. There is one easy way I know of remembering the table. Firstly, start by inverting the table. Put 90 degrees at the top. State that r is equals to 2. It might be a good idea, if you do memorize this table, to always write it in at the start of every exam or every calculation involving special angles. Then, do this. Under your x values, follow the order 0, 1, 2, 3, 4. And in your y values, follow the order 4, 3, 2, 1, 0. I then want you to put a square root over each of those. Square root of 0 is 0. Square root of 1 is 1. Root 2 is root 2. Root 3 is root 3. Root 4 is 2. And the same happens for the y values. This is the easiest way I have of remembering the table. There are other methods. You can choose whichever is best for you. But make sure that you do memorize it. The first example I gave you to do was sine of 90 degrees. Now, before we start any special angles at all, we have to first put down our table. 90 degrees, 60 degrees, 45 degrees, 30 degrees, and 0 degrees. Each has an x value, a y value, and their r is always equal to 2. The order that it goes in, if you got it, x value and y value is going to be 0, 1, root 2, root 3, and root 4, which is equal to 2. And in the opposite direction, 2, root 3, root 2, 1, 0. Find a way of memorizing this and know it so that you can put it down at the start of every, well, not of every special angle calculation, but at least at the start of every single exam on Maths Paper 2, so you're able to do these. Sine of 90. Now remember, sine is the function y over r. Of 90 degrees, the y value is 2 and the r value is 2. 2 over 2 is equal to 1. The next one was tan 45. Tan of 45 degrees is going to equal, now our ratios, sine is always y over r, cos is always x over r, and tan is always y over x. Tan of 45, tan is y over x of 45 degrees. The y value is root 2, root 2, and the x value is also root 2. Root 2 divided by root 2 is 1. That means that sine of 90 is the same as, is equal to tan of 45. But that's not what we're looking for. Number 3. Cos of 0. Now don't be too eager to just say 0. Sine of 0 is 0. But cos of 0 is going to be slightly different, and you're about to see why. Of 0 degrees, remember cos is the function x over r. X over r. So that's 2 over 2, which is equal to 1.